Students, let us continue with the concept paging. So in the previous video I just given an introduction of paging. So that is a non-contiguous memory location. So what is a virtual memory and how the pages will be stored in main memory. So the pages will stored in a non-continuous memory location. So whereas the frames will be divided storing in the main memory with the fixed size. So here you have to note that the size of the frame kept same as size of page. So always remember that the size of frame should be equal to the size of page, so that it can avoid, if you do like that, we can avoid external fragmentation. So whatever the size of frame, that size of frame is always equal to the size of page, means then there should no external fragmentation. So let me take one example here. So let us take, this is process P. So this is completely one process which is present in the main memory. Okay, whatever the process, so you just take it as a logical memory. So here the process is this complete process is divided into pages. The process is divided into pages. So first 100 bytes, second 100 bytes. So one process is divided into 100 bytes, so up to so on. So this process is divided into pages. So this you call it as page 1. This is page 0, page 1, page 2, up to page n. So I think you understand the concept of page. So in the process, in a single process, we are dividing the slots like the fixed sizes. So that is the pages. So these pages have to store in main memory. So how it is possible? So this is a main memory. So here the operating system is there. Now here the process P, page 4. And here F0, F1 or the frames. So these are the, so if you're talking about in the main memory related to the frames, and this is a logical memory. So whatever the virtual memory, that there is a divided into pages. Whatever the data that we are sending from virtual memory to main memory, so that will be sent in the form of pages. And actually the main memory is divided into frames, frame 0, frame 1, and here the process, here it stores the page 0, F2, and process P, page 2, F3, and page 1 here, F4, and like that. So divided into up to pages for the further operations up to Pn. So now this page 0 stored in here in frame 2, and page 1 come to frame, stored in frame 4, and page 2 stored in frame 3. And after that, whenever the operation is over, if you want to make the main memory free, you can swap the data into secondary memory. So this is a secondary memory which holds the data which is not used frequently. So just like a disk. So whenever the process is over, again you can swap back to main memory. Whenever the main memory is free, you just swap back to the main memory. So this is how the paging concept will be done. So first the process, one process we have taken, that process will be divided into pages, and pages will be stored in the main memory and becomes the frames now here. So it occupies the frames, and these frames, we are just accessing the frames. Now let us see the address translation. So how the address translation will be done in paging concept. Address translation. So in address translation, the page address is logical address. So I said the page address, whatever we are storing the pages, the page address is logical address and represented by logical address is equal to page number plus page offset. So this you have to remember that the logical address is always consisting of page number plus page offset. And coming to the frame address is called physical address, because we are storing that frames, we are dividing the main memory into frames. So the main memory is nothing but it is having the physically installed memory. That frame address is called physical address and is represented by physical address is equal to frame number plus page offset. So here not the frame offset, this is the page offset. So physical address is equal to frame number plus page offset. Logical address is equal to page number plus page offset. So a data structure called page map table is used to keep tracks of relation between a page of a process to a frame in physical memory. So just I'll take a simple example here. Suppose this is a CPU. This is CPU. The CPU is sending a process, that is a logical address. The CPU is sending the logical address with page number and offset. Page number and page offset. So this page number and page offset will be stored in page map table. This you call it as page map table. So in page map table you are having the page number and the frame number. So with the help of this it again goes to, so this comes to the physical address, frame number. So the logical address is converted into physical address. So with the help of this page number, so there is a relation, whenever the page number, that the related frame will be there, that will be moved to here, and with the help of this we are storing in main memory. So this is a main memory, first operating system, and F0 frame 1, frame 1, frame 2, frame 3 up to frame n. So this is how the concept address translations will be done. From the CPU we are taking, this is the logical address, and here when you want to access the main memory you have to convert it into physical address. So whatever the data that we are taking, the process, this is a process P. So we are taking in the logical and it's stored in the page map table. With the help of the page map table we converted into physical address with and send the data relating to frame number and offset, and that will be stored in main memory. So here when system allocates a frame to any page, it translates this logical address into physical address and create an entry into page table, which is to be used throughout the execution of the program. Okay, I hope you understand. Let me take a simple example for this so that you understand what exactly I am saying here. Suppose this is the page. This is the page and this is offset. Again the page number, frame number. Page number, frame number is present in page table like this, and again the frame number and the offset. Okay, suppose if I want to let me write here frame offset. Suppose the page number is 3 and the offset address 428. Now coming to the page table. So in the page table, the page number 0, 1, 2, 3 are there, and the frames numbers are related 1, 16, 7, 28 are there. So by seeing this page number, the control will come to this page 3. So here the 478 is offset. Here 428 and the 20 is there. So by seeing the offset, the controller first come to this offset which is present in the physical address. So now this page number coming to this frame. So this is a logical physical address. So the 20 frame number and 428 is the offset. So whatever the page and offset, the 3 and 48 is converted into 20 and 48. So this is how the conversion will be done, the page and of the offset. The paging concept will come like so. Let me take one example. Suppose this is a main memory. My main aim is to explain about the paging and framing. 0, 1, 2, 3, 4, 5. So this is a main memory, and here starts from frame 0. This is frame 0. So the main memory is divided into frames. Frame 0, 1, 2, 3 up to 5. So again, now the main memory, in each frame we are storing a data A0, A1, A2, and this is all free space. Now again in the main memory I am storing another data in the frames A0, A1, A2. So it occupies the next free space B0, B1, B2, and the space will be there. So here I load A, load process A, and here I load process B. Now again I want to load process C. A0, A1, A2, B0, B1, B2, C0, C1, C2. So here I load C. So I load process A, process B, process C. Now I want to swap out of the B. Whatever the B this is there, I want to swap out. Because there is no free space here, the B I am not using. So I want to just swap out that. A0, A1 and A2. And B0, B1, B2 space is remaining here. B0, B1, B2. C0, C1, C2. So this will be unused here. So what I had done here, I swap out B to disk, means to the secondary memory. I just swap out B to disk. Then the freed memory can be used by another process. So whatever the free memory here it is there, it can be used by another process. So now again, now I want to load process D. So this is the main memory. I want to load process D. But process D I am having D0, D1, D2, D3. So 4 frames will be there. So how it is possible? So this is A0, A1, A2. It occupies the space which is free here, D0, D1, D2. So up to D2 it can fit here. C0, C1, C2. Again D3 will occupy here. So there is a chance here, if you divide the main memory into frames, so whenever the process is not fitting here, you can split that process and you can store in another frame. So this is D and this is D. So I divided this complete process into 2 partitions. So this is the 3 frames will occupy here, and the remaining frame will occupy in the next location. So this is the concept of paging and framing. Okay, and coming to the advantages and disadvantages here is, paging reduces external fragmentation. So that is the main concept here. Why we are using this paging concept? To reduce external fragmentation. How can it reduce external fragmentation? Because the number of pages should be always equal to the number of frames, so that it reduces the fragmentation, external fragmentation. So advantages and disadvantages. First one is paging reduces external fragmentation. But still it suffers from internal fragmentation. So this is the disadvantage, but still suffer from internal fragmentation. Paging is simple to implement and assumed as an efficient memory management. It is simple to implement. Due to equal size of pages and frames, swapping becomes very easy. Swapping becomes very easy because of equal sizes of pages and frames. And page table requires extra memory space, so may not be good for system having small RAMs. So it is not suitable for small RAMs. It is not suitable for small RAMs. So this is about the concept of paging. Thank you.